Hello everyone, today we're going to be talking about conditional probability. So if you recall, we did go over the definition of this last time, and that is a conditional probability is the probability that event B occurs given that A has occurred. And we would write that as P of probability of B given A. So for these first two examples, we're going to use a table to find conditional probabilities. Number one says a quality control inspector checks for defective parts. The table shows the results of the inspector's work. First, we want to find the probability that a defective part passes. So here, another way we can think of it is that we want to find the probability of a part passing given that it's defective. And so we have a conditional probability here because we are assuming that the part is defective. Now we want to find the probability that it passes. And so to find that probability, I'm going to take the number of defective parts passed and divide it by the total number of defective parts. So looking at this table, I see that the number of defective parts that passed is this number right here. So I have 3. And now I need to divide it by the total number of defective. Well, I see that in the defective row, 3 passed and 36 failed. So the total number that were defective is 3 plus 36. So that comes out to being 3 over 39. And when I divide those two numbers, I get approximately 0.077. So in other words, there's a 7.7% chance. Okay, let's look at the second part. The second part says find the probability that a non-defective part fails. So now we want to see the probability that if I choose a non-defective part that it fails, so the probability that fails given that the part is non-defective. So that means it's going to be the number of non-defective parts that failed over the total number of non-defective. So looking at this table, the number of non-defective that failed is 11. So it's going to go on top. And then the total is going to be 450 plus 11. So that comes out to be 11 over 461, which when we divide that is approximately 0.024. So in other words, a 2.4% chance. Let's look at one more problem. So this one says the table shows the number of species in the United States listed as endangered and threatened. First, I want to find the probability that a randomly selected endangered species is a bird. So in other words, if I want to find the probability that it's a bird given that it's endangered. So I want to say probability of randomly selecting a bird given that it is endangered. So I want to go to the endangered column. I want to see what the number of birds are, and I see that number is 80. And then I want to find the total number of endangered species in general. And so that's going to be 70 plus 80 plus 318. So it's going to be that entire column. So 70 plus 80 plus 318, we get 468. And then 80 divided by 468, you get approximately 0.171. So this is going to be a 17.1% chance. Okay, and then part B says, find the probability that a randomly selected mammal is endangered. So this time we're looking at just the mammals. So that's going to be our given. And we're seeing from that group of mammals, what's the probability that it's endangered. So this will be written as probability endangered given that the species is a mammal. So now I'm going to look over at my table and I look for endangered mammal. I see that number is 70. And then I'm going to put this over the number of mammals. So that's going to be 70 plus 16. So I get 70 over 86. And when I do 70 divided by 86, I get that this is approximately 0.814. So there's going to be an 81.4% chance. So something that you may notice is that whatever is the given, that total number is going to be on the bottom. So here we had the total number of endangered. For the second part, we had the total number of mammals.